Hello. Let me get myself on there. There I am. Welcome to the stream. David Snowpeck here from Snowpeck Games. I am very tired today, so I apologize if I make a lot less sense than usual, but we'll see how it goes. I don't know. Is this microphone always on this side of my face? I feel like it should be over here. This is maybe a symptom already of my sleep deprivation. I can see that Micah is here rocking a crown. Debatably a king or astronaut or beekeeper. I'm looking pretty cool too. I got like the like old soldier look. I've got some kind of armor and then the gray beard and hair. We're looking good today, Micah. How is everybody doing out there? How are your folks' projects going? Anybody playing anything cool? I have been I think it's meant to be a crown. I mean, I've spent a lot of time with these assets. So I think that's what it's meant to be. But yeah, how are your guys' projects going? Anything interesting going on? You playing anything cool? I have been playing for the last like 2 weeks Cyberpunk 2077 again, which I played originally like the moment it was released. I took 2 days off of work. I remember it was coming out on a Thursday, so I took that Thursday and Friday off of work, and I downloaded it to my PlayStation 4. I have a base PlayStation 4 like 24 hours in advance, or however, PlayStation lets you do it. And then at like midnight on Wednesday, which I guess is technically Thursday, I started playing it, and I played it for like that whole, that bit, and then the weekend. And I know a lot of people who were playing on the base PlayStation 4 were saying that it's unplayable and all that, and that's why it got all the bad reception that it got. But it wasn't unplayable for me. I was able to play it. I played it saving a lot because it crashed a lot, so you'd have to, save every 5 minutes. But luckily, it's one of those games where you can save every 5 minutes. But yeah, it was a good game. It was a good game. And then I didn't think about it for 2 years. And I started playing it again a couple of weeks ago, and I'm having a lot of fun. Still a good game. It's not like the most amazing game ever, but it's a good game. I like it a lot. Anyway, yeah. Nobody else is offering what's going on with their projects, so I guess let's talk about what we're doing today. By the way, if you say something in chat, you get a cool character on the overlay. This overlay that we built on stream a little over a year ago. It's a Godot game. Yeah, get yourself a little character on there. Make me feel not quite as alone. So, I'm not entirely sure what we're going to be working on today. I need a little help deciding. We're definitely going to be working on getting WebXR going in Godot 4, but there's 2 ways we can go with that. So we could keep working on what we were working on last week, which was rendering stuff. We were trying to get multiview rendering working in the OpenGL renderer, and I can explain what that means. Or we could work on porting some input changes that were made to WebXR in Godot 3 that aren't currently in the Godot 4 version that relate to getting input working when you're using WebXR for smartphone AR. And the input stuff, we're like pretty much guaranteed to get that working. Like if we work on that, we'll make it happen. It'll be working. Maybe we won't get it done in time, but like we won't hit any serious roadblocks. The rendering thing, however, I am stuck, and I'm not entirely confident that in 2 hours I could get unstuck. Although maybe you guys could help. I don't know. I'm not that good at rendering, but if anyone who is here is better at rendering than me, perhaps we can figure it out together. I don't know. It's like a decision between a thing that's definitely going to work, but isn't that interesting, and something that's like really interesting and important. Like we need to render both the left and right eye. We can't just keep rendering the left eye. But we might not actually accomplish anything. So let me know what you guys think, what you want to work on. I asked on Discord for people to vote, and 2 people voted, and they both voted for opposite options. That survey, that vote did not help me at all. Oh, hey, Jive, welcome to the stream. You got a pretty cool character. Bald dude with a beard and what looks like a sweater. I'm going to assume is a sweater because I love sweaters. Here to learn, absorb knowledge. Yeah, I think that is how it works. You just listen to all the streams and the knowledge just soaks in. Micah's been playing Omega Strikers and working on the distraction timer. Thank you so much again, Micah, for working on that distraction timer. I don't know how in working on it for like 4 weeks or 5 weeks or however long I worked on it, I did not get it to the point where I could actually use it, but you are totally carrying the torch. Thank you so much. All right. Let's, anybody have an opinion on which of the two things we should work on? I'm personally kind of leaning towards sticking with the rendering stuff, even if we can't get it working, because that's more exciting, and I'm a sucker for exciting things. So I guess I will start explaining multi-view rendering for folks who weren't here last week, and then if anyone has a strong opinion that we should do one or the other thing, please let me know in chat. So one of the challenges with doing VR is that you have to render both a left and a right eye. You're basically rendering there's two ways you can do this, right? So in Godot 3, the way it's done is it runs the whole graphics pipeline for each eye in turn. It does the whole graphics pipeline for the left eye and then the whole graphics pipeline for the right eye, meaning you're essentially rendering like twice as many frames, which is tricky because you also have to render at like 90 frames per second when you're doing VR. But multiview is this extension that you can enable that lets you render both eyes at the same time, and you're essentially just doing like twice as many vertices and twice as many pixels. So you can imagine that instead of having the scene one time, you have the scene 2 times, and you're just going through each step of the rendering pipeline for both eyes at the same time. When you get to the fragment shader part, you're rendering twice as many pixels. You could sort of imagine that your screen's just double wide. And according to the Oculus folks, you get, in general, about a 40% performance improvement by doing it that way. Also, multi-view is kind of the basis of how VR rendering works in Godot 4. We don't really have a choice. We can't do it any other way. There is multi-view rendering support in the Vulkan renderer in Godot 4, but not in the OpenGL renderer yet. And we need to use OpenGL because WebGL is the basis of WebXR. Mike was originally going to vote for working on multiview, but I saw my vote would tie the poll, so I voted for the more popular one. What's the more popular one? They were tied, I think. Unless your vote came in late. I remember seeing it just being 2-2, and one of the 2s on each side was me to put the little emojis on there. So yeah, last time we, I think, got multi-view rendering working in OpenGL on the desktop. Hey, Crabsoft, welcome to the stream. This guy again. Why does he keep turning up on Twitch? You got a really sweet character. Actually, you're almost the same as my character. You're my doppelganger. You just have different pants and a shield. And I guess your armor is a little bit different. I don't have the pokey shoulders. Jive would just be happy to see more stuff bouncing around the screen. All right. So last time, I think that we got multi-view rendering working in OpenGL on the desktop. Oh, 2-4. 2-4. Okay, hang on. I gotta go look in Discord to see what's going on here. Some late votes must have appeared. Oh, and someone just joined the Discord. I don't know if you're on the stream, Surreal, but welcome to the Discord. No, I still see 2-2. Does it like not refresh or something? I'm gonna like reload my Discord. It's probably not a thing I should be doing on stream, because who knows what can happen. Hey, Carlos Patio, welcome to the stream. All right, I reloaded. Oh, geez, it did go up. Okay, it says 4 on input. What the heck, Discord? You weren't updating this for me? I'm actually a little, I'm a little surprised, honestly. So, okay. Who of the folks who voted for input are actually here on the stream? Because I'm totally fine doing that. It's just it's going to be pretty mechanical. We're just going to take the Godot 3 PR that we made. We actually did these input changes that I'm talking about bringing to Godot 4. We did on stream for Godot 3 back in January. I think it was January. So we're going to be taking that code, that patch, applying it to Godot 4. and then modifying it until it works. So it's nothing nothing super exciting. I don't know how long it will take, even though it's not like tough. It still could take 2 hours to do, right? Because coding isn't necessarily the fastest thing to do. But yeah, sort of to finish my thought, because I feel like I've said a couple of times that last time we got multi-view rendering supposedly working on the desktop. I'm starting to doubt that it is actually working, though. Like, I don't know. If I run what we did in RenderDoc, it gives really weird results. Like it's saying that we are not rendering to 2D texture arrays, that we're just rendering to normal textures. And yet it appears that we're rendering 2 different views. Of course, it's super hard to debug anything going on in the GPU because you can't actually get in there and see what the data is. You have to draw the data on the screen to see what's going on. All right. Micah ties it up. Okay, here's what we'll do. We'll start working on multiview, and if we are too frustrated with multiview by the halfway point, we'll maybe like switch to the easier thing. Hopefully that's a good compromise. So yeah, so the end of the stream last week, we got it supposedly working on the desktop, and then we started to look at how to get it working in WebGL. I kind of got stuck on how not knowing how to get access to the multiview extension in WebGL from C++. Like if we were writing this in JavaScript, I would know exactly how to get it, but it was a little bit unclear on the way to do that. I worked on that off stream, and I have an approach. I don't know if it's going to be the best approach. Once we get this actually working, I will ask Fabio, the HTML5 maintainer for Godot, to take a look at it and see if he'd rather it was done another way. But it was sort of a wild goose chase, because the mscripten documentation says everywhere, like, you don't have to load extensions, like, we'll load them for you, and we have support for all the extensions, and they'll statically link and all this stuff, and it just wasn't working. And then I decided, okay, I'm going to go read through the mscripten code, which I've done a number of times. Like, mscripten, it does weird things. You sometimes do have to go read through the source code. By the way, mscripten is part of the tool chain for compiling from C++ to WebAssembly. So for anyone who doesn't know what that is. But it turns out they don't actually load all extensions. They load like 5 extensions. And multiview isn't one of them. So I came up with a different way of doing this. Basically, each platform in Godot has like what its OpenGL header is set to a define. Here, let's try and find this. We want to be in the web platform. This is not where I want to go. I take it back. Okay, let me just. I'll just browse there in the file explorer here. Not core, not drivers, not modules, platform, and the web platform, rather than pointing to a system OpenGL header, points to its own special Godot WebGL2 header. And what I did was I added to this header a function that I'm defining in JavaScript that will replace the function that's supposed to come from the extension. This is actually kind of a normal way to do this. Like if you look at the way that OpenGL is loaded on desktop, it's loaded with GLAD, and it basically defines like a whole bunch of its methods, which are all named like glad underscore the actual method, and then it defines them over. So like this isn't a totally weird way of doing it. But yeah, so I have some code somewhere that loads the extension, and then I have this bit of code here that gives us access to this special method that we need from the extension in order to essentially bind our 2D texture arrays to a frame buffer to use the multiview extension. I hope any of that makes sense. And it seems like it's doing what I want it to do. Like I've put all kind of debug statements in here, and it seems like it's doing what it should be doing, but I'm getting an error when I actually try to run it in WebGL saying something like the number of views doesn't match, or like I forget what the actual, here, we can go look on the issue, on the PR. Because I've got a draft PR going with this. Add multiview to the OpenGL 3 driver. Yeah, the number of views in the active program and draw frame buffer does not match. So the active program is stating that it needs 2 views, multiview, left and right eye, and it's saying that the frame buffer we're drawing to does not have 2 views. So this, combined with some weird stuff I'm getting out of RenderDoc, is making me think that this might actually not be working on the desktop, and the desktop drivers are just being super tolerant of whatever mistake I'm making. And so we got to figure that out. Yeah, I had, I think, 2 pull requests merged for 4.0 Beta 2, and I got mentioned in the release notes for Godot 4 Beta 2, which I just love being mentioned in things. Like, I don't know. There's this thing like artists are always complaining about getting paid in credit, in what's the right word? In attribution, like oh no, we'll say your name and that's good enough. And people are always complaining about that. For me, like, it would totally work. Anytime my payment is my name getting mentioned, I'm a very happy person. Yeah, exposure, getting paid in exposure. Thank you, Ryan. And it's been a long time since I've chatted with you. I hope you're doing all right, man. All right, so yeah, so the other thing that I'm saying is that RenderDoc is giving weird results. And maybe we should just look at that because it is super weird. So how are we going to start RenderDoc? We are going to go to where I have it, which I think is here. Oop. So yes, load this with this app. We're good. So RenderDoc, for folks who don't know, is this tool that intercepts all of the calls that you're making to the GPU, so that you can look at them and make sure that it's doing what you think it is doing. Because again, like debugging programs running on the GPU is super hard. So here's the app running. I'm going to click, which supposedly should switch it into multiview mode, but for some reason it doesn't actually do it when we're running from RenderDoc. And then I hit print screen, and here, if I click again, you'll see like the view changes, and that's because when we switch into VR mode, it puts the camera up at like average height, at like whatever the built into the mobile XR interface has decided is average height. But that's how you know it actually did, like on Godot's end, switch to that mode. Okay, so here are all of the graphics calls that are supposedly happening. These calls actually like look right, but if we look at, what do we got to look at? Hang on. So this frame buffer is, no. So somewhere I can get it to show me the actual texture that we're rendering to. I guess we only have 2 textures in the whole program. Yeah. So one of these might be the back buffer, which we would expect to be 2D, just a normal 2D texture. But one of them should definitely be the render target that we are supposedly rendering the left and right eyes to, and it's saying it's a GL texture 2D, and that's not right. For multiview, you need to render not to a 2D texture, but to a 2D texture array that has 2 layers, one for the left eye and one for the right eye. Hey, Logan, welcome to the stream! Oh, I missed what Ryan was saying. Ryan's doing great, working on some little projects for the Playdate. That is awesome. Yeah. My buddy Elliot, who is frequently on the stream, but I don't know if he's here today. He certainly hasn't spoken up. Also got the Playdate, and it looks really cool. There's some folks on the Wisconsin Game Development Discord who are working on it too. Like, so I have a question. Have you done graphic stuff with it yet? Because like I'm always amazed at how the like 1-bit art looks really, really cool. And do you have to do the 1-bit art, or does it like automatically do some of that for you? Because like 1-bit art is really hard, right? But somehow everything I've ever seen anyone make for the Playdate looks amazing. Anyway, the playdate is very interesting. Definitely, when you got some games going, let me know, because I'd love to see that. And if you aren't on the Wisconsin Game Developers Discord, you should join the Wisconsin Game Developers Discord. Hey, Jared, welcome to the stream. Yeah, so the majority of the people in the Wisconsin Game Developers Discord are based in Madison. So if you're in Madison, you're in a good place. There's a bunch of game studios there. There's one of the offices that makes PUBG is there, and a bunch of other smaller ones. What was that company that worked with John Carmack on? I can't remember, but there's a bunch of Madison game studios. That's probably where most of them are in the state. But yes, the group is statewide. You should check it out. Really good folks. All right, so yeah, looking in RenderDoc, either RenderDoc is lying, which I would not be totally surprised about, but yeah, Raven, Lost Boys, PUBG, ZeniMax, yeah, and then lots of little ones. There's lots of good indie stuff going on in Madison too. And then coming up in not too long, in November, there's a developer conference in Madison, MDev, which I went to in 2019. And then the pandemic happened, and I haven't been back. But I'm going this year. I have my ticket already. It is set. So yeah, I'm going to try and stay on task roughly here. I get very distracted. So I have some ideas about how we might debug this situation. One is that currently the WebXR emulator doesn't seem to be working with WebXR and Godot 4. It was working, and then some changes to the OpenGL renderer happened, and then now it's not. And so it would be nice to get that working again. I think that would make it much easier to test. Right now, I either have to just assume that the error messages that I'm getting when I run like in the desktop browser are sane, even though it won't actually show me anything because it's broken. Or I have to actually run it on my headset, which is a huge pain in the ass. So that's one idea. Get the emulator working again, and then we can debug from there. And the other idea that I have to try and get to the bottom of this RenderDoc thing is to change the code to rebuild the render targets every single frame, which we definitely don't want to happen when this thing is for real, like in the wild, and we're running a real game on it. But it would mean that we get to see all of the API calls that we're making in order to create the render target in RenderDoc, and we can try and verify, like, are we actually doing the right thing? Because I don't know that we are. So, hey, Jared's doing some data-oriented stuff, database stuff. Madison is pretty great. It is a good place. Yeah, there's a lot of things, like the tech scene has a very different character in Madison than Milwaukee. I don't live in Milwaukee anymore, but I lived most of my life in Milwaukee. And definitely more like startup money going on there. Most of it in the medical kind of field, but it is definitely interesting. Anyway, so yeah, let's do a thing. Let's do some hacking. 23 minutes in, we haven't written any code. All right. So I don't know if anyone has a strong opinion, but I kind of want to try the thing where we make it rebuild the render targets every single frame, and then see what that gives us in RenderDoc. And if that gives us some leads, we can keep going down that path. If it doesn't, we can try maybe the fixing the emulator path for some easier testing. So we need to go to renderer viewport, I think, because I believe this is where so this is where, like, the Godot renderer, or actually like any renderer, like this is render agnostic code, will say, okay, it's time to render a viewport. It will look at the XR interface, and this looks like not exactly the right spot. This looks like the right spot. So it says, okay, are we in XR? Let's see if we have a valid XR interface. and then we are going to see what the render target size should be, and then we are going to set it. And this method does some magic to not rebuild the render target if something hasn't changed. We are going to get rid of this check. And there might be some more checks further down the chain, right? So here, it's calling it to texture storage, which will then branch off to the different texture storages, whether that's the texture storage for OpenGL or the texture storage for Vulkan or DirectX or whatever. So we're going to have to take a look at that code and make sure that it isn't also checking if things changed. So let's dig a little deeper here. We want texture storage for the OpenGL driver. If the size is equal, return. Okay. Wait. This code seems wrong. Even if this isn't the problem, like this code seems wrong. It needs to also check if the view count is the same. So we're going to get rid of this. We're going to get rid of these lines. We're going to comment them out. But that's definitely wrong. Because what if the render target size doesn't change, but the number of views has changed, which could very well be the case with the test that we're doing. Okay. So comment unclosed at end of file? That can't be true. What are you talking about? What are you talking about, VS Code? You're wrong. All right, let's just move on. So clear render target. Let's just make sure this is doing something that looks sane. Yeah, pretty much. And let's look at update render target. See if this is doing something sane. Yeah, if it's a negative or 0 size, don't try to build it. Here's some of the code I added. I don't know if this code works. This should only run on Android, but I don't have a good way to test this on Android, but I hope it's good. Clayjohn will tell me, or someone will tell me, hopefully. Maybe Fredia, I don't know. Or maybe this will get pulled out at last minute because I have no way to test it, but yeah. That's supposed to get multiview set up for running on Android. Yeah, all this code seems good. All this code seems good. Let's compile this. I'm just going to quick look in git diff just to give one last like sanity check. What? I am a lot confused right now. Why is this change happening? That shouldn't be happening. Or this change. Where'd those changes come from? Maybe there's some old cruft left in my working directory here. Oh no, that's actually something else. Okay, so here's my diff. There we go. Those are the changes we expect. All right, let's build this, and then I'll see what folks have been saying in chat. Oh, not much has been going on in chat. I thought I saw some blinking over here. The joys of C++. Waiting for the compile. Ooh, Logan had an interview this week for a full-time Godot dev job. That's awesome. 40 hours of work to do a test project. Haha! That already sounds like a good gig. That already sounds like a good gig in that they first are thinking not just about what you say in your resume, but want to see what you can actually do, and they are willing to pay you in order to test you and see what you're going to do. That sounds like a good. That's good signs for them as an employer. Just being good folks who treat their people well. But yeah, I hope that goes well, man. Yeah, when we were doing a lot of C++ stuff, I used to make lists of things that we could do when we were waiting for compiles, but I didn't do that this time. Logan says, yeah, they're awesome. I really enjoyed the interview. Yeah, that's great, man. I hope that works out. Lots of cool Godot things going on lately. I'm trying to think of anything else that's worth chatting about. Ooh, the build finished. Oh, on the VR end, Godot 4 is working in some I don't know how well it's working, but it is working with the Quest now, which was one of these things that was pending for a long time. Okay, so here we're rebuilding. Things still seem to be working. It's actually crazy, like how many things with Godot 4 are kind of coming together at the last minute. You know, like there was a lot of things that were maybe probably not going to end up in Godot 4.0, and we're like, okay, that'll happen in 4.1, but so much stuff is just sort of falling into place at the last minute. Doesn't mean that it won't end up being a buggy mess, but it is really cool to see that happening. Okay, so we made our change. Everything still seems to be working. Let's try running it in RenderDoc. And now, whichever frame we capture should include the creation of the render target. All right, so I'm going to click. It's not going to work because something. I'm going to hit print screen. And we captured a frame. We'll close this. It's loading our capture. Let's go see what happens here. This seems like not enough calls. So clear. Okay, so some are getting kind of baked in here. All right, all right. We are binding to a texture, frame buffer texture 2D. This might be the back buffer. I don't know, guys. It still like really looks like it's creating a 2D texture, not a 2D texture array. What the heck is happening? Does anyone have... I didn't mean to click that. Does anyone have more experience with RenderDoc and like experience with it lying? Because it just seems where... Here, this is what I wanted. Go back to where you were before, please. Come on. I want you there. That's not exactly what I wanted. Oh, whew, there we go. Oh, hey, Jared's working on a WASM extension for Godot. Cool. Before using a new extension API, not to use source a little bit. WASM time. No, that would be really cool. Having a way to build extensions to Godot that in WASM, so you don't have to like compile your GD extension for every single platform that you want it to run on. Time to relax and focus. Welcome to the stream. You got a pretty cool character. You got kind of the caveman shirt with the braids and a sweet hat. This is so crazy. Is RenderDoc lying, or is it actually doing this just totally wrong? So let's try running through this in the debugger, which I have done, but not with it rebuilding the render targets every frame. So we can at least see on the C++ end. I don't know what these breakpoints are about. We want breakpoints where we are creating the color attachment for the frame buffer and where we're creating the depth attachment, which I know we're doing at least one thing wrong for depth, but that doesn't seem to be what's happening here. I like disabled the depth pass, so even though I know we've got a problem in the way we're handling the depth pass, it shouldn't be the issue here. Okay, so we are going to put a breakpoint here where we are setting the render target size, or actually maybe let's go a little deeper. Let's go into the actual OpenGL renderer and the update render target. Let's put our breakpoint in here. And we're creating the color texture. The depth texture gets created somewhere else. I'm not sure where. I don't remember exactly. Oh, I know where it is. It's in render scene buffers, but not exactly here. The GLES version of this. Render scene buffers, GLES. Here we go. And this is where the render target texture is put on a frame buffer together with a depth texture. Okay. Did you put Godot for beta 2? I mean, we're working from the master branch, so it's not exactly beta 2. It's actually probably a little bit before beta 2, but after beta 1. Beta 2 is working great, though. I've been using it on projects locally, but we are actually hacking on Godot here. Is there a branch for what you're working on? I wouldn't mind grabbing my quest and hacking on this. Yeah, this is in core. So this PR, which I guess I'll put into chat, is the code as it stands. It's a draft. So I've been pushing to this for a couple of weeks now. When did I create this? I created this 26 days ago. It's almost a month I've been working on this. And it only really kind of started working last week. All right, so let's run this with the debugger, with our breakpoints, and we just need to know that our frame buffer that we are actually rendering to has its color texture and its depth texture as a 2D texture array and not just a plain 2D texture. And I'm in like this stage of debugging this where I just don't even know where the problem is. There's always that long period of time where it's like, where even is the problem? And then once you find it, it's usually relatively quick to actually, you know, figure out what the heck is going on. Okay, so this, we're hitting this right away because we're now rebuilding every single frame. So I'm going to mute the breakpoints, hit play. Then I'm going to click to get us into VR mode, and then I am going to unmute our breakpoints, which should immediately hit them. And we're starting up here in render scene buffers. I honestly would have expected to end up not here first. I would have expected to end up here first. Okay, so we're getting the render target. Let's step over this. What the heck happened there? Step over, man. There we go. Okay, we stepped over. Let's take a look at the render target in memory here. FBO number 1. And the render target should have a view count of 2. We've got our size here. That seems kind of wide, honestly. Or maybe not wide enough. That sounds too wide for one view, but not wide enough for 2 views. Because this should be 1920. It should be 1920 on the width. Interesting. Interesting. Do we have access to the XR interface in here? Doesn't look like it. Next time I see the XR interface, though, I'm gonna see what it's returning from its render target size. This is still weird, though. Why are we here first? Why are we here in render scene buffers first? We should definitely have ended up here first. Unless this breakpoint's in a weird spot. I know sometimes that happens. Where like I pick a line to have a breakpoint on it, but like GDB just doesn't see it. So I put a couple extra ones. All right, so if we go here, we're going to keep going, blah, blah, blah. So we're now, this is creating... So wait, we're binding... Okay, so we've grabbed the render target. We are creating a new FBO to be our render buffer. We have seen that we have more than one view. Great. We are going to... I don't know that we even need to do this. I don't know that we need to bind the texture before calling this line. But whatever. I don't think it hurts anything. So then here is when we are telling the multiview extension with this special method from multiview that this is color attachment 0. We're giving it the view count, which let's just make sure that's right. Okay, our view count here is 2. Oh, that's on the render target. I want to make sure that it's right. Where are we getting that from? From the argument of p view count is also 2. Okay, so they match. We're good. So that seems right. Now here we're creating the depth texture. So we've created a new texture resource. We are filling it with data, or not filling it with data. We're allocating the data for it, but not putting anything in there. That's what the null pointer is. Then we are setting some texture parameters. We are then attaching it as a depth attachment. Okay. But why do we not end up here first? Okay, so now we are over an update render target. And I'm going to step over this stuff. I'm just going to sort of step over lines until I see it go into the branch that creates a 2D texture array. Okay. And then we end up here again. I just don't know what frame we're on. Okay, okay, we're gonna mute. All right. This is running. Then I'm going to unmute. And again, we're ending up at render scene buffers first. Doesn't that seem odd? When you post stream, would you mind dumping on once you have your tasks to go into the draft PR? That would be awesome. Yeah, sure. I mean, unless we make some like breakthrough here, I am kind of stuck on this problem. I thought they replaced OpenGL with Vulkan. Yeah, so Godot 4, like Godot 3, has swappable rendering backends. And so Vulkan is the primary one. There is also an OpenGL renderer, which we need for anything web-based, because this is for WebXR, right? VR apps that run in the browser to provide an immersive VR experience. So like if you're on the Quest 2, for example, you open the Oculus browser in your headset, go to a web page, hit some Enter VR button, and then it takes over your environment, and you can play whatever experience that developer has provided you. But it's all WebGL. And WebGL means we're going to be using the OpenGL renderer in C++ land, which mscripten is going to translate into WebGL calls for us. One day, we will have WebGPU, which will be closer to Vulkan in kind of its design. But as of now, like WebXR just doesn't work with WebGPU, not yet. And WebGPU is still like pretty fractured. I guess like they ended up creating their own shader language. Whereas like earlier implementations were just using SpearV, which is the binary form of the shader language for Vulkan. So like I think Chrome and Firefox still use SpearV, and then like maybe it's Microsoft and Apple or something like use the new shader language. So like I don't know, you can't even really do WebGPU in a cross-platform way anyway. So eventually WebGPU will get itself sorted, and then WebXR will implement some way to use WebGPU with WebXR, and then we'll have that. But for the time being, it's all still OpenGL land. Okay, so I'm going to look at the call stack here. Not this call stack, the real call stack. What are you talking about? What is this? Okay, there we go. This is what I want. And see, how the heck are we ending up here before we're ending up at the other place? So you get draw viewports. Right, so render viewport. We're calling viewport set size, which lands us here. but we should have ended up here first. We should have ended up in render target set size first. Maybe what I'll do is I'll set the breakpoints here instead of here, instead of where they are right now, and then we'll just sort of step to those places. Maybe that'll make this make more sense. I'm going to, that's the one I did want. Get rid of the other ones. Okay, let's try this again. I'm going to say go run. And did it do it? Are we here? Okay. So now we've started another frame, presumably. Yep, main iteration, rendering server, draw viewports, viewport set size. So first things first, we need to set the render target size. So I'm going to step into, which is going to be a little weird. Or no, it went straight here. Did it? Yeah, it went straight here. Cool. Sometimes that has taken me down through like some pointers and stuff to actually make it to the correct texture storage, but that just worked, which is awesome. So now here we are at set render target size. I'm going to step over, then we're going to step into. All right, so let's make sure that this is calling this is going down the right branch and calling the right methods to create a texture 2D array. Yep, looks like it. And then it's going to bind it with the multiview extension. Brilliant. Checks frame buffer status, all this. I don't think there's anything else here that we need to happen, so I guess let's just keep stepping. Or no, you know what I'll do? I'll put another breakpoint here. So we should, if I just hit play, we should go down to that line. Yep. Configure 3D render buffers. So now step into. And this should eventually get us to the code where it rebuilds our render buffers. Internal size. I'll step into this one. Oh, here we go. Now we're going through some weird pointers. I'll just keep hitting step into, which will hopefully get us where we need to go. I don't need to see the construction of the vector. Oh, geez. Is it going to take me through each of these vectors? Probably. Yep. Okay, I'm creating another vector. All right. We like vectors. They're good. Okay, so now we end up here where it's supposed to take that render target that got created. Something we should maybe do is like actually check the IDs. Make sure that the right ID thing is getting passed in. Okay, so we get our render target. We've already looked at this code before, but we weren't sure the order that it was running. We still have this 15 is the texture. Yeah, like when it created the new render target, did it create a new ID for it? Or did it like reuse the old ID? That wouldn't make any sense though, would it? Okay, let's keep going through here. We're making 2D texture array. And we're doing all the things to it. We're initializing it. Debuggers are so important. We're troubleshooting. You go through step by step. Yeah, for sure. I wish we could debugger the code that's running on the GPU side. So create the frame buffer, bind the frame buffer. Where does this frame buffer object go? Where does this frame buffer object go? Oh, okay, so that's a property of this class? Must be. Yes. So render scene buffers GLES3. I actually didn't realize that this was like an instanced thing. Do we have more than one of these? Do we have more than one render scene buffers? That'd be a little interesting. So viewport has render buffers. So okay, we only have the one viewport. Let me look. Viewport. Render viewport. This is in the render server. And it has is that render buffers? Render buffers. Render scene buffers. I'm a little curious too about this render target texture. I don't remember ever doing anything with a render target texture. Let's look in here. No, it's like not referenced at all. Is that like left over from something? Okay. So wait, we're now in the render server, which is generic code. How did we get here from the OpenGL code? So over here, we are in render scene buffers GLES3. We got here from here. This frame buffer. Main frame buffer. Depth texture. Internal texture. Render target. Oh, okay. So this descends from the render scene buffers. It's the OpenGL implementation of that class. I just have this worry that like we're creating the frame buffer, but then like rendering to a different frame buffer, right? And again, I just like don't feel like I can trust RenderDoc. So I don't know if what it's telling me is true. But yeah, so we created a new frame buffer. At what point do we actually like say, okay, please render to this? That would be probably in render scene renderer. Oh, so many things, so many renderers. This is again generic code. We need to be in the GL ES3 code. We find my way back to some GLES3 code here and see if we can see the class we need to end up in. So rasterizer canvas, probably not. Rasterizer scene, that sounds like what we need to do. Okay, so we start rendering. Okay, this is exactly what I wanted to find. Okay, so we build this frame buffer, and then here, presumably, is where we start actually drawing to it. And what is this method? What are we in? Wow, it's one long method. Render scene. Sounds good. We want to render the scene. And we bind this frame buffer that we presumably just created. Hopefully we're not using some random other frame buffer. And we're not using a depth pass because I turned that off in the project settings for the project we're using. So we don't have to worry about anything happening in here. At what point are we rendering the actual scene? Okay, so we're rendering some sky. I wonder if we should turn off the sky rendering. Just to have less things going on, so like less things can happen. Render 3D transparent pass. Pass mode color transparent. I hope that doesn't happen. And then debug draw. So wait, where's the normal pass? Is this the normal pass? Where's the normal color pass? Alpha, color pass. Pass mode color transparent. Okay, let's find every instance of this method, because it looks like this method does like a full render pass, and then we have these different kinds of render passes, like the depth pass and this pass mode color transparent. Let's just find all instances of this. Okay, here is a normal color pass. And then here's the depth pass. All right. Why does transparent happen every time? That is confusing. Let's go into here. So transparent is basically the same pass as the color pass. Like, what changes with transparent? Transparent, then if current depth pass does not equal shader depth test, then shader depth test equals depth test disabled. Could we just not do a transparent color pass? That'd make me feel a little happier, less things going on. I mean, we could comment it out. I just don't know what would happen there. Well, anyway, it does seem like we were binding to the right frame buffer, unless we bind to a different frame buffer later. We just look for all bind frame buffers here. Sky radiance frame buffer. Yeah, this is also a problem. When I was running on my headset, it was telling me that there was no radiance map, no cube map for the radiance, which seemed legit. It seemed like there actually wasn't one. And if we could just not do that too, that would also be nice. Update radiance cube map. We could just not do radiance. Okay, so here's where we're unbinding frame buffer. Then we're binding it again. Okay. Okay, hang on. So here we bind the right frame buffer. And then where are we binding this radiance business? This is at 857. Is that... Okay, so we're looping around there. So we bind this frame buffer, and presumably it stays bound through here. Unless that sky stuff happens in here. Let me search for sky. Yeah, okay, so some sky stuff starts happening. Draw sky. And then is this where that frame buffer gets bound? So the sort of idea that I'm trying to chase down here is maybe we're binding to a different frame buffer and then forgetting to rebind back to the original one. I don't even know if we are drawing a sky. So here we have draw sky. Let's just see if we're doing this at all. We should be able to just hit play in the debugger, draw sky. Nope, we're not drawing a sky, which might be why the whole radiance map thing is not happening. Man, does this just not seem like it's doing the right thing? Like, it really does seem like it's doing the right thing. And RenderDoc is just lying. Okay, let's Google. We're gonna Google here. RenderDoc multiview OpenGL. And we might have to actually Google. I'm using the Brave search engine right now. RenderDoc with, no. Multiview, no. Okay. Let's use actual Google. The results from Brave's search engine are usually not very good, unfortunately. So RenderDoc, multiview, OpenGL. RenderDoc, OpenGL. Render view. Let's put multiview in quotes. Doc. I don't even know what I'm looking at right now. The RenderDoc API reference. Let's search for multiview. Shader vertex message location. The vertex view. Okay, so like it appears that it has some support for multiview, but why does it do like such weird stuff? This is like my least favorite thing about rendering is you like never really know what's going on. Is RenderDoc lying? Or is my code doing something weird? Are we not ending up with 2D texture arrays, or are we ending up with 2D texture arrays? Yes or no? Okay, let's start this loop one more time. And I'm just going to keep track of IDs, and if this doesn't give us any useful information, we're trying something else. Okay, so this, if I step into it, we'll rebuild our render target. So clear render target should just destroy our previous texture. All right, we have some zeros. We have a 0 for color. Then we are setting the size, setting the view count, update render target, step through here. We are setting some things on the render target structure. Texture equals get texture. So this is getting our texture struct. Creating a frame buffer, a new frame buffer for the render target. So FPO1, that's crazy that we get number 1. There aren't any other frame buffers. All right, so we bind to that. Now we're going to generate the color texture. What is this? What is this object even used for right now? Okay, so it looks like at the end of this method, once it does all of its work, it takes this texture struct and it sets a whole bunch of properties on it, including the texture ID. So that's good. Okay. So now we're creating this texture, creating an ID for it. Bind, allocate the data. Let's go look here. Color is 15. I don't know how it always ends up being 15. Setting the stuff on it. All right. So now I want to look at the render buffer. We're going to step into here. which, let's actually just jump all the way, not here, all the way to the OpenGL version of this. So renderer. Oh my god. Okay, I can never remember the names of these things. They're all named so similarly. I think it's this. Render scene buffers GLES3. We're going to end up landing over here, where we're now going to take the same texture from our render target and bind it to an FBO, which is what we're going to actually render to, I think. So let me just continue to end up here. Okay, so now we're making a frame buffer for the render buffer. So we generate an ID. What ID do we get? I guess that's on this frame buffer 2. All right, so this is a new, totally different frame buffer from the render target one. I'm going to bind to it. We're going to bind to our 2D texture array, which I'm not sure we actually need to do. But anyway, that's on RT color 15. All right, so we're binding to that. We're saying do your magic multiview with the right view count, I hope. Need to look on this. Where's this? This view count 2. Okay, it's using that view count. Did we update that up here? Yes, we did. We updated it up here. Then we're generating a depth texture. See what ID we get for that. 40. That one gets up to 40. We always get 15 for the color. Even though we destroy it a bunch of times, it somehow always comes back as 15. The depth texture is 40. Okay. We attach it to the depth attachment. That all seems good. Then we switch back to the system FBO. Should just be 0, probably. Just verify that. Yep, 0. It just like really seems like it's doing everything right. Redraw. Does this do anything interesting? I don't think so. No. I don't even know why I'm stepping through this code. I think does all things that are fine that don't relate to what we're trying to do here. Get down to our viewports. Last pass does not equal draw viewports pass. Render the viewport. Yeah, this should be a no op. Set external texture should do nothing. The GLES3 version of it. Texture equals 0. This does not equal 0. And then it frees it up. Does some other things. I'm just gonna go into this code. I don't know. I'm just watching what's happening. I don't think this is gonna mean anything though. Yep, it just jumps straight to the end. Okay. Draw a viewport. Step into here. Draw a viewport. Geocompatibility. Make window current. Oh man, okay. I was wondering how long that loop was gonna go. And render buffer and not valid. Okay, so if the render buffers were not valid at this point, it would have created them. Clear. What are we clearing? We're clearing the viewport render target, which I think is the back buffer. I think. Not entirely sure. Now draw 3D. Draw some 3D. Get down to render camera eventually. Some more XR interface stuff. I'm just going to jump down here to a little further in the process. This is all code we actually messed with last stream. We were trying to get the camera information for both eyes saved and passed in the right place. We get to set multiview camera. That should be doing what we want it to be doing. And render scene. And up here, set scene pass, render pass. What render pass are we on? Render pass plus plus. Okay. Is that just counting? Like, yeah, 869. I don't know what that's supposed to mean. Okay, set render pass. Render buffers. Yeah, we don't have to worry about SDFGI. Stability. Let me just sort of scroll down in here a little bit, see if there's anything else that seems like it might relate to what we're doing. I don't think we're using shadows. I'm going to jump down here just to see if we are. We are. Shadows are a thing. That's interesting. Okay, well, I guess we need to keep shadows on our list of things to worry about. We are not doing SDFGI, but we probably will run some of this code, if nothing else, to just say count is greater than 0, will not have any count. Yep. Render buffers. Render scene. I think this now gets us closer to things that are important to us. Yeah, so this takes us down into here. This is where the scene will actually be rendered. I think we were looking in this code a little bit earlier. So this RB here, this should be our render buffers. Let's just verify it is not valid. It looks like it's not valid, right? Yeah, or is valid. Is valid? Okay, so the render buffer is being passed in is valid, which then gets assigned to this RB. Okay, I don't know why this code even needs to exist. Okay, so now when we look at our IB, we have a reference, we have a render target with a depth texture of 40, a frame buffer of 2. That all seems fine. Or wait, no, the render target, we're just getting a pointer, and then the frame buffer of 2, though, that's right. So I remember it being that being the ID. Okay, throwing some stuff in here. We added, or maybe didn't add, but like was looking at this exact code last stream. I know we added one of these loops. I don't remember if it was specifically this one or if it was one in a different part of the code. Debug draw. Okay, some clear color stuff going on. Tone map UBO. I don't think tone mapping even happens currently in the OpenGL renderer. Clay said he just hasn't ported it yet. Set up lights, set up environment, render list. Okay, we're binding to the frame buffer we want to actually draw things to. This frame buffer is the one that we watched get set up that should be correct. We should not be using a depth pass. Let me just verify that that's true. Use depth pre-pass is true. That shouldn't be true. Or did I not run the line yet? Or config use depth pre-pass? Use depth pre-pass. Okay. Use depth pre-pass. Depth pre-pass. We are doing a depth pre-pass. I thought I turned that off. I guess not. So maybe the issue that I was talking about before, where I know we're doing something a little bit wrong for depth, maybe that's the whole thing. My plan was just to avoid that by not doing a depth pre-pass, but all right, let's go here. What? Okay, well that didn't work out. I wanted to step into that code, but it didn't really let me. We may need to come back around in order to see this. Yeah, okay. Let me clear out some of these previous breakpoints, and we are going to set a breakpoint here, and we're going to see which passes we are actually running. So it should be the next frame. Why are we on this line though? That's just weird. I'm just gonna hit this again and see. Okay, that's the line it wants to go to. Maybe it'll go up one. Okay. So this is where it's deciding which shader variant to use. We made 3 new shader variants for multiview, basically just like changing some defines on the color, depth, and additive variants of the shader. So, okay, we are doing a depth pass. Wow. I really didn't think we were. So this is good to know. Not entirely sure what this code is doing. Someone who's better at rendering, come save me. What are these elements? What are we looping over? What is this? Are these the different like bits of geometry that we're rendering in the scene? Could be. Seems like it could be. Setting some material data. Okay. Scene state, current depth draw, shader depth draw. We didn't do anything there. Okay, just skipped that whole section when I hit step over. Call front, call back. Call back. Some culling gonna be going on here. Jeez. Okay, so we're getting the actual vertices that we're gonna render. Yeah, since I've been so focused on just this one piece of the renderer, I haven't been in any of the stuff associated with like the vertex storage. All right, okay. Shader variant. So mode depth multiview. Instance variant, we add 1 to the shader variant? That's interesting. So what is instance variant? What is that? Instance variant. Okay, it's just another num, it looks like. If previous shader does not equal shader and previous shader does not equal instance variant, then we do some stuff. This is interesting. So previous shader set to 0. Current shader set to something. Previous variant set to color. So set to depth. It really there was no previous pass. This is the first pass of the render pipeline. Okay, so version bind shader. What exactly is this doing? This is version bind shader, version variant specialization, blah, 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 blah. Take me to that code. I want to see that code. Okay, so it's finding the shader. It's finding the right ID for the program for this particular shader, and it is setting it. It's doing use program. I don't really understand how it's doing that with this stuff, but ultimately that's what it's doing. Okay. So let's go back to where we were. Pass mode, depth, pass mode, shadow, blah, 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 blah. Version set uniform. So I imagine this is setting a UBO somewhere. Geo storage. Version set uniform. Opaque prepress threshold. Oh yes. GL uniform 1F. Version get uniform. Set uniform. Yeah, I don't know what that is. Let's just let's just keep going. See what we find here. It's doing something with setting uniforms, I guess. I don't know if it's worth digging deeper to figure out exactly what it's doing. Multi-mesh. Don't do anything with that. Yay! Using regular mesh. I'm happy about that. Then we do draw elements. It looks, or I don't know if we're using an index buffer. Who knows? Okay, we are. Cool. That's fine. And then we're going to the next. And then that was all. That was all that needed to be drawn. It drew all the things in a depth pass. And then we keep going. Find ourselves on the other side of the depth pass. Use the depth prepass. Okay, so the thing that I know we're doing wrong for the depth prepass, if we go look at what is the actual shader, it's scene GLSL. I didn't fix this because I thought we weren't using a depth pass, but down in the fragment shader, I think, let's look for depth. Yeah. Okay, so this depth buffer is marked as a sampler 2D. It is not a sampler 2D. We just went through a lot of code, stepped through a lot of code verifying that it was being created as a 2D texture array. So we say if def multiview, this actually needs to be a sampler 2D array. The screen texture, I don't know what that even means. Does that mean the actual screen back buffer? Probably not, because we haven't drawn to it yet, unless it's the screen texture from the previous frame. But it's possible that should also be a a sampler 2D array, but I don't think we're actually using them anywhere. Yeah, we're not using these anywhere. So let's just live dangerously and pretend that they both need to be 2D texture arrays. Don't you want it to be an array if it's a multiview? Yeah, so the depth buffer definitely is. like I know it is an array. The screen texture, but I don't know what that's referring to exactly. So the back buffer will always be, I think, unless I'm like just completely wrong here, which I could be because it's rendering and I'm not that good at rendering. I think the back buffer will always be just a normal 2D texture because the back buffer is your screen and your screen only has one layer. But the depth buffer definitely is an array. But if this is referring to the screen that we're drawing to for the scene, then it would be a 2D texture array. Oh, yep. You're right, Micah. I reversed them. Thank you. I have them backwards. Okay, so multiview is the array, and then the not multiview is the sampler 2D. Okay. How are we already like a half hour to being done with this stream and we've got nowhere? We've got nowhere. Okay, so now that we know that the depth pass is definitely happening, I would be curious to see if this has some positive effect. Because later, we actually bind the depth buffer to, in the color pass, we'd be binding the depth buffer as a uniform here. This is making me wonder too about what does the back buffer even mean in a VR situation? Because I've been operating under the assumption that the back buffer needs to stay as a texture 2D and not a texture 2D array. And I don't know that that's the case. I don't know what I'm talking about. Rendering. Oh my gosh. Why can't we do something easy like online multiplayer? And I know that online multiplayer is like really hard for a lot of people, but for whatever reason, like online multiplayer is my jam. Like I'm good at that. I understand that. Rendering is hard. I have no idea what the heck I'm doing when it comes to rendering. Okay, so we did this depth prepass, right? And then we're going to come to the color pass. And when we come to the color pass, we'll end up here again, right? So let's jump in here. And let's just watch where it's going to bind this depth buffer. If we can see it, if we can notice it. So if it was color pass, active texture equals, oh yeah, so we're going to -2, whatever -2 is. I guess we can check here. Which texture is -2? We're going to search for text unit -2. That's the radiance map, which I know we don't have. So, okay. We're going to bind something to this radiance map, which I don't think we have. So render data environment is valid. Then we do nothing. So what was this texture to bind? Now I want to know. Because looking at this code, I wonder if this should actually be this. Because I feel like we should always bind something. Or not. I don't know. I'm so confused. All right, so let's again see if we can see where we're binding the depth buffer to a uniform. Stake our names is not equal to draw depth. Skip that. Some culling stuff. I don't really know what it does. Okay, again, here's where we're loading the vertex data for what we're about to render. I did not even see it bind the depth buffer. Did you guys? Or has that not happened yet? It's got to be in this stuff here. Version set uniform. It's got to be in the set uniform stuff. Bind light indices. Set uniform. Transform. Actually, hang on. So these must be the uniforms, right? These must be the actual uniforms that are getting set, I think. If we go look at this, yeah, these are the actual uniforms. Is there even one for the depth buffer? Doesn't seem like it. Doesn't seem like it's actually even binding the depth buffer. So the thing that we changed, like that I just changed in scene GLSL, I don't think it's going to matter. Because it doesn't look like it ever binds anything to it. Unless I'm just not seeing it. So text unit -5, -6. Let's just search for -5, the regex. A minus and a 5 in the same line. All right. Search for a minus and a 6 in the same line. I don't know. I don't know. It honestly seems like none of that should matter. What pass is this? Another color pass. Okay. I don't know. Maybe we should have done the input stuff. Jianju69! Welcome to the stream. Which channel are you responding to? DSnowpack is inactive. I don't think I'm inactive. My Twitch channel, I believe, is not DSnowpack, though. I think it's Snowpack Games. Someone else got DSnowpack. I should be rocking out here at Twitch TV, Snowpack Games. Let's create an infinite loop. See if we can do that. There I am. Create an infinite loop. See if we can do that. There I am. Create an infinite loop. See if we can do that. There it goes. There it goes. Okay. I don't know. I don't know where to go next. I don't know where to go next. I guess, like, RenderDoc has to be lying. I don't see where we are rendering to the wrong type of texture unless the back buffer also needs to be a 2D texture array. Like, texture 2D array. Yeah, I don't know why RenderDoc is lying to us. I don't know what is going on there. We should have maybe done the input thing. We should have maybe done the input thing. I'm just not sure where to look next. Like we could, okay, so what are some things we could chase down? Where's my notes? Need my notes. We could try. WebXR and Godot 4 notes. There we go. Send this to this screen. Yeah, so we tried this. No difference. But we can try and see what's going on with the back buffer. See what's going on with the back buffer. Maybe nothing. It could be possible that it just doesn't get used when you're rendering to a VR headset, to an XR device. Yeah, the WebXR emulator. I wish that RenderDoc wasn't lying to me. Like I need some way to get some insight into what the video card is doing, like what we're sending to the GPU, and it's telling me we're sending something that like I just don't see us sending. Let's go look in. I don't know Vulkan at all, like literally at all. But let's go see if we can figure out what the Vulkan renderer does with the back buffer when in XR mode. Which might be another wild goose chase. I hope not. So that would be not here, I don't think. I don't think we actually need to go to Vulkan, because that should just be setting it up. What we actually want to see is like renderer RD. Where is that? Renderer RD. Somewhere in here. Where are we? We are in rendering, renderer RD. Okay, that's where it lives. And probably storage. Probably render buffers, maybe. No. Okay, well we at least know where the code will be. So let me search in here once I can get to the top. Rendering render RD. Say find in folder. Back buffer. It's in the canvas renderer where it should be. That's for flat stuff. Texture storage. I wonder if somewhere in the OpenGL renderer, it's trying to draw the 2D stuff on top of the 3D stuff. And the problem isn't that we're rendering multiview to a single view destination. What if the problem is that we're rendering a single view source to a multi-view destination? That's actually something I haven't looked into at all. Okay, what if we are rendering a one view source to a two view destination? So in Godot 3, when you went into XR mode, it would completely just get rid of everything 2D. Like it would not try to render 2D to the main viewport. And I don't know if that is the case or not in Godot 4. Hey, Aaron Winter, welcome to the stream. You got like a blacksmith going there with that beard. Here, let me see what I don't have chat up on my screen right now. Yep, we are doing C++ today, Mr. Winter, and we are not making a lot of progress. We've eliminated a couple of things as being possible ways to solve the problem. We tried some things that did not work. I don't know why, but I feel like this code should be this. I'm just going to leave that there, and later I'll come look at the diff and like consider whether that is right or not. But C++ scares me. C++ can be scary. The way that Godot does C++ is relatively straightforward. It's pretty good. You can get really out there with metaprogramming in C++. Oh, sorry for the yawn. But Godot doesn't do any of that junk. It does like very limited stuff with templates. And of course, memory management's always a little bit scary in C++, but are there cases where we overlay 2D on top of 3D, such as pop-up dialogues? Maybe we should convert it to a billboard in 3D before we composite. So in VR, like, you definitely, even if it is possible for it to draw the 2D stuff on top of the 3D stuff, you probably shouldn't, because it won't look right. It'll look weird. It'll hurt your eyes, because you need the two eyes to be different to get the stereoscopic, like the right stereoscopic effect. So from an application development perspective, you absolutely should not put things in 2D space. But I'm wondering if the Godot renderer will do it if you ask it to. And maybe this is the whole problem. Maybe the problem is in Godot 3, when you go into XR mode, it disables drawing the 2D stuff to 3D, but what if that's not being disabled? What if it's actually doing it? See you later, Logan! Thanks for coming! And maybe that's the whole problem. I wonder if that's the whole problem. Let's see where 2D comes into the equation. Where does 2D come into the equation? So renderer scene is all 3D stuff. Rasterizer scene GLES3. So rasterizer canvas GLES3 is where the 2D stuff gets rendered. And here we go, the back buffer FBO, all this stuff. At what point does that get put on top of the 3D stuff normally? And maybe we just need to stop it doing that. Just don't do that. Canvas begin. Where do these things even get called? I've not spent much time in the 2D renderer in Godot 4. Actually, no time at all have I spent in the 2D renderer. So renderer, canvas renderer. Let's go look at its parent. And what I'm looking for is some of its kind of like top level methods so we can see what would be the entry point here. Canvas render items. That sounds reasonable. Let's search the code base for that method. Or I could try to ask VS Code to do it, but it doesn't always work. So go to references. We'll see. Find me some references. I need them. Oh, it worked. Okay. So, or it didn't work in the way that we needed it to work. Oh, here we go. Renderer canvas call calls renderer canvas items, which comes from render canvas item tree. I just need to find the place somewhere in the code. It's saying, draw the 3D things. Okay, draw the 2D things. Okay, put them together. And I just need to find where that code is. Render canvas call, render canvas. I guess go to references again. Renderer viewport. Here we go. We're going back to renderer viewport. Our old friend renderer viewport. Okay, so what happens is we draw 3D. We walked through that. We walked through that probably way more than we should have. We went all through there. And then here it looks like it is doing the canvas rendering. Oh, and it's doing 3D rendering again later. What? Okay, if scenario, draw canvas background, canvas map, begin canvas, layer, blah, 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 blah. What? What is happening? I'm very confused. Okay, maybe we didn't go through that code, but we went through some adjacent code. It calls draw 3D a lot of times. Okay, so we definitely went into here, Draw 3D. Let me just look at this code and make sure it's the code I think it is. It is. Okay, yep. So draw 3D really does go draw 3D. It triggers all of the XR rendering and everything. Render canvas takes us to render canvas item tree. But that's not where I want to be. We already looked at that. Where I want to be is render viewport, draw 3D before here. Okay. So draw viewport, draw 3D. Okay, when scenario is not draw canvas background and draw 3D. Which one? Okay, here's what we're going to do. We're going to again use our friend the debugger to figure out what code is actually happening here. Assuming that the debugger is not going to just, well, maybe not, maybe this code isn't happening. We might need to restart. We might need to restart this this app. We've been in here for far too long. Hey, Alexei Smirnov, welcome to the stream. Everyone is afraid of things they don't understand. I was afraid to learn Godot, and I'm going to use it. I love it. Yeah, that is true. Oh, I changed some code. We're recompiling. No, I shouldn't have changed that code. Let me go see what I changed. I didn't check to see if Alexei appeared on the overlay with the Cyrillic characters in his name. Maybe he wouldn't, but I'd be very curious to know what happened there. What does happen there? Linking, always linking. But I don't know, guys. I think this might be. I think we might be onto something. I think we might be onto something. That maybe the problem is that we need to disable 2D, and or at least disable drawing the 2D onto the 3D. When multiview is happening, because we do want it to happen when we're doing smartphone AR. When we're doing smartphone AR, we want it to draw the 2D on top of the 3D, but when we're doing VR, it just can't work because again, the stereoscopic effect. You'd hurt your brain if you had identical 2D things appearing over your view in VR. And actually, we need to start out by muting these so we can make sure that we switch to XR mode. It can work. No, yeah, it can work if you render it in 3D space. Yeah, you're not a... Oh, there you go. There's your character, but it doesn't write your name. I should fix that. I should try and figure out how we can get Cyrillic letters in there. Okay, here we go. We are in, for the billionth time today, draw viewport, and we're going to step over here. So that's where we drew our 3D. I saw it go in there. All right, if not disable 2D, we're going to go do some 2D rendering that's totally unnecessary. Render target mark SDF, blah, 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 shadow rect, cold 2D lights. Yeah, I mainly, like, we would want none of this to happen, right? But I want to see the code that's actually combining the 2D and 3D to, like, verify the idea that this could be the problem, right? And then once we look at that code, we'll try disabling 2D rendering entirely and see what that gets us. Okay, so we got some canvas map items here. I feel like some of this code may have already happened. Render canvas. Hey guys, it's passing in the viewport render target, a render target that we know is a 2D texture array and not a texture 2D. I think this is conceivably the problem. Let's what can we do? What is the easiest way to make sure that 2D does not happen? Viewport disable 2D. Can we set that on the main viewport? I don't know if we can. Let's see how easy it is to comment this out. So where does this go to? All the way down there. So 556. We need to comment, not delete. We need to comment out like 300 lines of code here. And I don't know if there's any C-style comments in there. And I don't feel like finding out. So I'm going to cheat. And I'm going to put C++ style comments here just on every single line. All right. All right. Now, we need to build this, but to actually test it, we've been testing on the desktop. The error doesn't happen on the desktop. We need to actually build this for the web, for WebXR. So that is build, and HTML5. Hopefully this won't take a million years to build. Is clear request to do clear request? Yeah, okay. So what we would want this to be ultimately, if this turns out to actually be the problem, is we want to check up here we check if viewport disable 2D or view count is greater than 1. Okay, this is going to get to the end. This is going to get to the end pretty quickly, I hope. And we'll need a test case. Where's my latest test case? I think it's in games, G4, GL, ES3. And we'll need to rebuild it. That will be... I haven't tried building this with Godot with beta 2 yet. I don't know if we should build it with beta 2 and live dangerously, or if I should just do this with beta 1. We got to wait for this to compile. And it's on the linking phase, the slowest phase. And then we can export our test project. We can set up a little Nginx server, then open it in the browser and see what happens. And actually, I can show you guys in the browser right now the error, because I only talked about it and actually demonstrated on stream. Set up a little Nginx there, and then we're going to go to here. Let me open up the dev console first. Yeah, I need to switch to a different font. I spent all that time localizing Retro Tank Party. I have Retro Tank Party running in Russian, Ukrainian, Chinese, but both simplified and traditional, and Japanese and German and Spanish, and yeah, I have the fonts. I have the fonts available. Yeah, okay, so here's the actual error. I don't know if you guys can see that. It's super tiny down here, but the number of views in the active program and draw buffer does not match. And I had assumed that that meant the number of views in the active program was 2 and the draw buffer had 1. Because that's the whole thing we've been tackling this whole time. But what if it's the reverse? That is the theory we are trying to test. What if the active program has 1 view and the draw frame buffer has 2? So let's see where we are at. We are still building, but we are past the linking. We are to the zipping stage. The zipping stage should be faster than the linking stage. All right, done building targets. Let's go over here. We will export again. Export for project preset web has failed. Why? Why has it failed? All right, let's not use beta 2. Let's use beta 1. That was successful in building the project, or exporting the project earlier. Why? Why is it failing? Or no, that's not what I want. I want export presets. Web, and here's the files. What is failing exactly? What the heck? Project export for preset web failed. Why though? Why is it failing? Oh, you know what? I'm missing an argument. Haha. This is my fault. This is my fault. I have to actually put, it won't use the path that's saved in export presets. For some reason, you have to actually give it the path. There we go. Okay, it has exported. We've got about 4 minutes to see if this works, which I guess is really just one try, pretty much. It's either going to work or it's not going to work. For good luck, I'm going to stop and restart Nginx, and then we're going to go over here. We're going to refresh. Here's the moment of truth. I'm going to click it. No. No, that wasn't it. That wasn't it. Unless there's more code that's doing the same thing somewhere. Number of views in the active program and draw buffer does not match. Just double check the little hashes here. This is BD206. Let's go over to our code. BD206. I don't know. It seemed reasonable. It seemed like a thing that could be. Do clear request? How does this clear request work? I'm assuming it's just calling GL clear. Clear color, frame buffer. Clear colors. Draw list begin. Oh, it's rendering device. Okay, we're in the wrong place. We landed in the wrong place here. We need the texture storage for GLES. Clear buffer FV. Yeah, that should work fine. That's not a program. That's not a thing. I mean, other than like if I compiled this wrong or put it in the wrong place or like something like that, it seems like this didn't work. I'm just going to sort of verify that I didn't put it in the wrong place. Let's just, we'll build this one more time. We'll build it one more time. Just look at what the file name is that it builds. Or maybe it won't tell us again because it doesn't need to build it again. We'll verify it some way or another. I really thought we were onto something, guys. I really did. So wasm32.zip. Pretty sure that's what we're using as in our export presets here. Yep. Home dsnowpack prj Godot 4 bin web debug wasm32.zip. You could try, just for the heck of it, clearing out everything in the web directory, building it. We're not building it, exporting it. We've already built it. Export went down. Nginx. And back to the web browser. Refresh. Still no. Man. Well, we've been on a journey, my friends. We've been on a journey. I'm sorry that did not, that we did not find the answer. We probably should have done the easier thing. We probably should have done the input. And maybe we thought of the right thing. Maybe this thing about drawing 2D onto the 3D is actually the thing, but I didn't find the right place to disable it. I don't know. Well, thanks everyone for coming to the stream. It is always a little bit depressing coming to the end of a stream where we did not succeed, but that is life. That is how development goes sometimes. But yeah, thanks everyone for coming. I hope you have a good weekend. And I will talk to you on Discord or elsewhere. Take care, everyone. Bye-bye.